Here's a quick look at the user interface for the CFC modeling activity. Here we have the input boxes that we can control, the initial concentration in parts per trillion, the lifetime, which you should never change because the lifetime of CFC12 is 100 years, the initial emissions in parts per trillion per year, that's the total amount of CFC12 emitted into the atmosphere each year, and the growth rate in that emission. So if this were set to be 10%, after 1 year, the emissions would go from 10 to 11. These run buttons allow you to run the simulation in just different colors. Sometimes you want to put multiple simulations all on the same graph. The run 1 is a little bit of a finer line so that you can get a little bit better precision when you're trying to tweak things to the model observation, models to the observation. In the first part of the activity, what you want to do is you want to adjust the emissions, the initial emissions, to get a good fit between the model output, the red line, and the data for the first 5 years or so. The other thing that you will want to do at different times is use the model to estimate the emissions at different times. And the idea is to match the steepness of the graph for the data with the model, or vice versa. Match the steepness of the model line to the data. For example, let's say I wanted to find out what the emissions were in 1990. Then what I could do is adjust this, let's say, to 400, and then maybe say estimate it's 20, and run that. And I'm looking to see, well, that looks about the same steepness. So let me drop this down, 350. Okay, this looks like it may be a little bit too steep. The model output is maybe a little bit too steep for the data right there. So I'll drop this down to 18 and run it again. Now my graph is getting kind of cluttered, and so I'll just press the clear button and run that again. And then I'll drop this down maybe to 340. And again, I'll clear that, maybe 335 for the initial concentration, which effectively just shifts the line downward. And now looking at the value here, it looks like I've got a pretty good fit to the steepness of the data values compared with my line. And so this would mean that the emissions in 1990 are pretty close to 18 parts per trillion per year. It's a pretty good estimate. Notice the steepness earlier in the early 1980s, or most of the decade of the 80s, the steepness was a little bit steeper. The black dots had a little bit steeper inclination, and so the emissions then were greater. But you could do that at any point. It is a little bit of a trial and error and tweaking around, but the point is, if you match the steepness of the observations with the model, then you've got a pretty good estimation of the emissions for that given time. The other buttons down here, you've got CFC number 1, that's kind of the default button where the screen opens up originally. CFC, I'll just click it again. CFC number 2 allows you to project into the future. It's a 200-year simulation from 1980 through 2180. CFC number 3 is another activity that focuses in on 1990, the data from 1990 through 2010. Actually goes through 2012, but the simulation is a 40-year simulation from 1990 to 2030. And then the very last one, the initial concentration starts off, or the initial model run starts off at 2002 and goes to 2042. Okay, and this allows us to see what's going on here a little bit more closely. Let me just run this real quickly. The initial concentration is set correctly here to start out with. The 2002 concentration of CFC12 was very close to 543 parts per trillion global average. But zero emissions is clearly not correct. So we need to start out with some initial emissions here and then a declining emissions likely, so a negative growth rate to get a good fit here. Okay, good. Well, I hope that helps you get started with the whole modeling project. Good luck.